All right, so guys, the section we're doing tonight, 7.4, is hypothesis testing for proportions. What I want to point out is this is going to be real similar to what we just did on our quiz, okay? So it says in much the same way that we performed hypothesis testing for the population mean mu, we can perform hypothesis testing on a population proportion p. This is particularly useful when testing claims over percentages of defective parts, likely voters, approval, so on and so forth. Okay, so here is one of the important parts. It's my z-test for a proportion p, and it says a z-test for a proportion p is a statistical test for a population proportion. The z-test can be used when a binomial distribution is given, and it's just saying that n times p is greater than or equal to 5, and n times 2 is greater than or equal to 5. The test statistic is the sample proportion. Remember, guys, we call that p hat. And the standardized test statistic is given to us using this little formula right here. So let's take a look. Like before, we can use our z-test. So like Jordan was saying, you can use the table or you can use your inverse norm. It can be used to determine whether or not to reject the null hypothesis, determine your critical values in regions based on level of significance, compute the z-score, your sample statistic, to make your conclusion. Okay, so guys, we're going to follow this piece here, kind of like the way we've done with the problems we did before, okay? So I'm going to just kind of shift to get to the next page where I have my problem. All right, so let's start reading. It says, a researcher claims that more than 30% of U.S. smartphone owners use their phone while they're watching TV. Okay, so I'm going to stop right there, guys, because this is telling me the what? The claim, right? Okay, so more than 30% use their phone while watching TV. Okay, so guys, this is going to tell me. So remember, I'm not talking about averages, right? We're talking about percentages. We're talking about the percent of people who use their phone when they're watching TV. So because we're talking about percentages, we're going to use our P here, okay? So guys, if P is more than 30%, what symbol would I use? Greater than, right? So P is greater than, guys, as a decimal, everybody agree? 0.30? Okay, so this is our claim. There we go, claim. Okay, then what is the opposite of saying greater than? Less than or equal to, right? It can be smaller than or it can be equal to that number. All right, so guys, now that we have that part, which is my HO and which is my HA? HO is on the bottom. Okay, so before we go on, do y'all agree that the HO is on the bottom and the HA is on the top? Okay, guys, how do we know which one is the HO? The equal to, right? As long as it has an equal to part, that's telling me that's going to be my HO, right? Okay, let's take a look at the next part. It says, in a random sample of 150 adults, 38% of them say they use their phone when watching TV. All right, so let's take a look here. I'm going to say my N. What's my N in this case? 150, right? Okay. Guys, our P hat is the sample proportion. So out of these 150, how many of them said that they watched or they use their phone? 0.38, right? So my P hat is 0.38. Okay. All right. So the next thing we're going to figure out, guys, is this a left tail test, right tail test, two tail test? What do we got to look at? We got to look at the HA, right? So if we look at the HA, that's pointing to the right. Okay. So this is going to be a right tail test, right? Okay. And we know that our alpha here is what number? 0.05, okay? So guys, the first thing I need to do, I need to find my critical value, okay? So I want you to think about this for a minute. Guys, whether I use my table or whether I use my calculator, my table and my calculator always tells me the area of which way? To the left. So my question to you is this. Look, if the area to the right is 0.05, what would the area to the left be? But hold on, what would the area this way be? Remember, the area under the whole thing is always going to be 1, right? So wouldn't the area right in there be 0.95? Okay, so guys, what I'm going to do, I'm going to grab my calculator. Okay. And let me see. Let me get out of here. Okay. I'm going to go inverse norm. Because my calculator tells me the area to the left. My area to the left is 0.95. Okay. Guys, I want you to think about it. What's the z-value that's right in the middle? Do you remember what the z-value right in the middle is? 0. Okay. So if we're over here, what kind of z-value should we get? Positive or negative? Positive. Okay, let's take a look. There it is. Okay. Guys, if you look at, I'm going to point this out real quick. Let me come over here. Okay, if you look at this little thing right here, let's see, 0.95. Let me see. Oh no, this is something. Oh, this is for. That's for the z-values over here, but I'm trying to make sure I'm coming up with the same thing. 1.96? No, we came up with what? 1.64? Okay, I'm going to use 1.64. I don't know why I was thinking something different over here. All right, so my critical value, 1.64, right? 1.64. Okay, so guys, now that I have that, let me do this. Let's go here. Does everybody agree that this is our rejection region and everything inside here is going to be our fail to reject region? Does that make sense? So far, so good? Okay. So guys, what we need to do now, we need to find our test statistic Z. Okay, so look, all I'm going to do is I'm going to scroll back up here. This is my formula for finding my test statistic Z. So I'm going to write that down. I want to say it says P hat minus P divided by, is it PQ over N inside the square root? Yeah, right? Yeah, PQ over N, all inside my square root. Okay. We're going to close that off with parentheses right when we do this. Okay, so guys, let me ask you a question. Do we already have a value for P hat? It's right here. It's 0.38. Good. Do we have a value for P? 0.30, right? So let me just write this right here. P is 0.30. Do we have a value for Q? Okay, so let me ask you a question, guys. If P is 0.30, do you remember what Q is? 0.70, right? Okay, do we already have a number for N? Yes, it's 150. Okay, so all I'm doing is just making sure that I have all my values, okay? So look, let's go ahead and do that. P hat, we said, was 0.38 minus 0.30 divided by the square root of 0.30 times 0.70 all over 150, right? Okay, so guys, let me grab my calculator so we can do this together. Let's clear this out. Okay, so we're going to go 0.38 minus 0.30. And we should get, what, 0.08? That makes sense? Okay, now divided by, guys, all of this is going to be inside the square root. So I'm going to go like this, square root. Now, see how my square root opened up parentheses for me? What numbers are we going to multiply? Okay, guys, can I go 0.3? 0.7? Okay, and we're going to divide it by what number? 150. Okay, I'm going to close off my parentheses right there. I'm going to hit enter. And let's take a look at the z-value that we came up with. Guys, to two decimal places, 2.13 or 2.14? Okay, so let me do this a little bit. So right here, I'm coming up with 2.14. Okay, so guys, let me ask you a question. Do we fall in the reject or in the fail to reject region? We're going to fall into the reject region because if this is 1.64, over here is going to be 2.14. Okay, so we're going to say we're going to reject the null. Okay. All right. Now, guys, if I look at my chart, right? If I take a look at my chart, let me come back here. Let me focus this thing. Okay. So my question to you, real quick, like if I switch back over, which was my claim, my HO or my HA? My HA is my claim, okay? So if I come back and I look at this here, my claim is my HA, right? And we are rejecting it? Okay, so what are we going to say to support the claim? Okay, so right here all I'm going to say is there is enough evidence to support the claim. Make sense? So far, so good? Okay. So now let's take a look at number 2. Okay. Number 2 says the research center claims that 28% of its college students, or 25%, excuse me, of college students think a college degree is not worth the cost. Wow, it's a pretty assertive claim. Okay, so guys, remember, because these are proportions, we're not using the mu, we're using the p, right? Okay. So look what it says. It claims that 25%. Is their claim saying more than, less than, or equal to? Equal to, right? So they're claiming p is equal to a 0.25. Okay. This is my claim. Okay. So what is the opposite of saying something is equal to? Not equal to. Okay. Guys, do you know which is our HO and which is our HA? Top is the HO, and the bottom is the HA. HO has the equal sign. So anytime you see the equal sign, whether it's equal to or greater than equal to, less than equal to, as long as you got the equal to, that's going to be your HO, right? Okay. So guys, now that we have that, second question. Left tail, right tail, two-tail test. Two-tail test because we always look at our HA. Okay, so look, we're going to do this. We're going to come over here. We're going to put a mark. We're going to come over here. We're going to put a mark. Guys, everybody agree that in the middle is going to be our fail to reject? And then these are going to be our rejection regions? Okay. All right, so my question to you is if our alpha is 0.10, how do we find the little pieces here? Divide them by 2, right? So alpha divided by 2, wouldn't that be 0.05? Okay, so this is going to be 0.05 and 0.05. Okay, so guys, if I'm going to find those two critical values, there's going to be two of them. One's going to be negative, one's going to be positive, right? Everybody agree we're going to grab our calculator, inverse norm, okay? And the number we're going to enter on the inside is 0.05, okay? So remember, we're going to get two z values. Okay, everybody agree, negative 1.64? Okay. So this one here, negative 1.64. This one here, positive 1.64. Okay. All right. So now that we have that, guys, let's see if we have some other information. Do we have our p hat? So let's take a look. It says, you decide to test this claim and ask a random sample of 200. What's that 200 anyway? That's my n, right? That's the number of people that we asked. So we asked 200 folks, okay? Whether or not they think college is not worth the cost, and those surveyed, 21% replied yes. Okay, so what number is that 21? That's my p hat, right? So my p hat's going to be equal to 8.21. Okay? So guys, all I'm going to do here, I'm going to write down my formula that we used earlier. To find my test statistic, I'm going to take p hat minus p divided by the square root of pq all over n. Okay. So guys, if we know right now, yes sir, pq. If we know right now that p is 0.25, what would my q number be? 0.75, right? Good. Okay. So let's go ahead and start writing this out. Okay, we said our p hat was a 0.21 minus 0.25 divided by the square root of, let's see, pq times n. So 0.25 times 0.75 divided by, what number was it? 200. Okay. All right. So let me grab my calculator and let's see if we can do this. So we're going to go 0.21 minus 0.25, okay, is negative 0.04. Okay, we're going to divide this by, isn't everything inside the square root? Okay, so guys, we're going to go 0.25 times 0.75 divided by, what was the number? 200. On my calculator, I got to close off my parentheses. I'm going to hit enter. Okay, and I'm coming up with a negative 1 point, but I put 3031. 31, okay. So, negative 1.31. Okay. So, guys, where would that negative 1.31 fall? In the fail to reject, right? So that negative 1.31 is going to be somewhere right about there, right? Okay, it's going to be in the middle. So guys, right here we're going to say fail to reject. The null. Right? Okay, now let me come back over here. Which was my claim? My HO or my HA? My HO, okay? So guys, when I come back over here, I'm going to zoom in just a little bit. Let me let it focus. Let's see. Okay. So our claim was our HO, and we rejected or failed to reject? We failed to reject. So what are we going to say then? There's not enough evidence to do what? Reject the claim. Okay. So right here, I'm writing over here on the side because I don't have a lot of room. There is not enough evidence to what? Reject the claim? So far, so good? All right, good. Hey guys, we got one last problem here. Let's take a look. See, it says a Humane Society claims that less than 35% of U.S. households own a dog. Okay, so let's see. Let's figure out what their claim is. P, less than what percent? 0.35? Okay. So guys, what is the complement? What's the opposite of saying something is smaller than 0.35? Greater than or equal to. Boom, equal to 0.35, okay? Now, the top one was the claim. I think it's always easier to write the claim because it's clearly stated. It's usually the first sentence, right? Now, between those two, which is my HO and which is my HA? Top is HA. There's my ha. And the whole, right? HO. HO always has equal sign, right? Okay, so let's take a look here. In a random sample of 400 households, so guys, isn't that telling me my N is 400? Okay. 156. So guys, they're not giving me the P hat yet, right? We're going to find our P hat a little bit. But they're telling me that the number of people who own a dog would have been 156. Do y'all know how would we find our P hat? Divide those two, right? So we're going to take what? 156 divided by, what was it, 400? And what, 0.39? Okay, so our P hat is a 0.39. Okay. Now it says at alpha is equal to 0.10. Is there enough evidence to support the society's claim? Okay, guys. Second question: left tail, right tail, two-tail test. Left tail test, right? How do we know? HA, right? So the HA is always going to tell me, how do I know what kind of test it is, right? Okay, so we're saying left tail test because it's going to the left. So there we go. And our alpha here is 0.10. So guys, if we're going to find our critical value right here, our ZC, what do you think? Positive, negative? Should be negative, right? Because the area is in there is only 10%. Remember, half would have been 50 and Z would have been 0 at that point, right? So second vars, inverse norm. We're going to enter in 0.10. Close it off. Negative 1.28. Okay. So, yeah, negative 1.28. Okay. Guys, everybody agreed that this is going to be my fail to reject? And this will be our rejection region? Okie dokie. All right, so let's find a couple of pieces more of info. Guys, we know that our P is 0.35. Does anybody know what our Q would be? 65, right? 0.65? Good. Okay. So look, guys, let's find our Z value. Okay. We're going to go P hat minus P divided by this big old square root of PQ all over N. Okay. So let me write them out so that we can do our calculation. Let's say we said our P hat was 0.39 minus 0.35 divided by the square root of 0.35 times 0.65 all over, what was our N? 400, right? Okay. So I'm going to grab my calculator. Let's clear that out. Let's see, 0.39. Okay. Minus, what is it, 0.35? 0.04, good. Divided by the square root. Okay, we're going to take 0.35 times 0.65. Oops. 65, okay. Divided by, what was our N? 400. Yes, sir. Okay, and enter. Guys, y'all coming up with 1.68? Right? 68 if I round to 2 decimal places, right? Okay, so 1.68. Okay. So guys, let's see. What do you think? Reject or fail to reject? Fail to reject, right? Okay, so we're going to go like this. We're going to fail, reject the null. Okay. Yeah, so 1.68 would be somewhere over here, right? Does that make sense? Good. Good questions, guys. Okay. So now, let's take a look. Okay, guys, which was our claim? The HO or the HA? The HA was our claim, right? Okay, so guys, if I switch back over here, right? Okay, look, we said our claim is our HA, and we failed to reject. So what are we going to say? There is not enough evidence to what? To support the claim? There is not enough evidence to do what? Support the claim, right? Oh man, my handwriting is horrible. Remember, guys, when I was in 2nd grade, elementary school, we had a handwriting class, and I got a D, and apparently it hasn't gotten any better. All right, so there's not enough evidence to support the claim. Okay, guys, I'm going to show you this just because it doesn't hurt to show you this, right? But I want to show you something here. So, like, if we do the same problem here, remember when we did our quiz and we tested we found our Z value by doing the whole calculation and said, look, we can do the Z test, right? So there's a way you can do this, again, just to confirm, right? Guys, if I go here to stat and I scroll over to tests, do you see number 5 where it says 1 proportion Z test? I'm going to go to that right there, and I'm going to hit enter. Okay, and all it's telling me here, the P0 is whatever the claim is, or the original proportions they gave me. What was the P0 it gave me? 0.35, right? So 0.35, okay? Now, in this particular problem, we didn't have the P hat, right? We knew the 156, so I'm going to type in my 156 right here, okay? What was our N in this case? 400, okay? Guys, left tail, right tail, two-tail test. What was this one here? Left tail test, right? So I'm going to go to, I'm going to scroll over here. I'm going to go to the one where it's left, hit enter. I'm going to go to calculate right here. And so let's see. Let's take a look here. Did we get the same z-value? Yeah, same z-value, right? Guys, do you see how now it gave me the p? It gave me that p hat. So the only thing is, I mean, you can do this, right? Just to double check. But I want to ask you something. When I was doing, say, problem number 2, did problem number 2 ever tell me, it told me the percent that replied yes, but it did actually tell me the number? No, it didn't, right? So to me, I would much rather just do this, because I'm not even, if I was going to do number 2 using this thing here, I wouldn't even have that x. I'd have to find that x. To me, that's already making me do more work. You know what I mean? So I'm just showing you that there is a way you can do it, but in my opinion, this calculation right here, it's pretty straightforward to do, right? Pretty straightforward to do. All right, so